Okay. Now coming to questions 35 and 36, these are from the linear algebra. What we're given with is a linear transformation P from a Euclidean space with dimension n to itself, and they have defined us the range and the null space. These definitions are essentially the definitions of what we call range of a linear transformation and nullity of a linear transformation. That is, the range would be take any vector from Rn, you just apply the transformation P to that vector, and what is obtained is in the range. And nullity is the set of all such vectors in Rn whose linear image is the zero vector. So now we say that this P defined so and so is a projector matrix, projector transformation if the definition, if these two conditions are satisfied. The conditions are the question itself. Okay, all we are required to show now is that P square is equal to P. I mean, we have asked a bunch of, we are given a bunch of options, but the only option that is true in this case is P square is equal to P, and we'll show this here. But before that, let's just understand what P represents. P is a projector transformation. That means you take any vector in Rn, what it does is it projects the components of the vector onto some other lesser dimensional plane, let's say. Now if you have a if you consider a three-dimensional space and project vector xyz onto, let's say, the xy plane, that is the R2. So we are given with x, y and 0. So this is what we obtain. That is P of x, y, z, and x, y, z here represent the components of this vector. So this is what will be one of the examples of a projector transformation. So, and in this case, what we'll have is all the vectors with only z component, that is all the vectors in the z axis will belong to the nullity. So once we've understood that, it's very easy to see that if you take a projection of any vector twice, we'll get the same vector again, same result again. So consider any vector x and consider P square. Just what to do is apply P twice, and we can represent x as y plus z, where y belongs to the range and z belongs to the nullity. And since P of y plus z is nothing but y, and since z is siphoned off, we are left with P of y. And again, y is nothing but P of y plus z, and y can be represented as y plus 0, where 0 belongs to the nullity and y belongs to the range. And therefore, this indeed belongs to the range of this, and P square is equal to P, because P of y plus z is again P of y. Therefore, we have the correct answer to this is option 3, which is P square is equal to P. Now coming to question 36. In this question, we are given with another transformation Q, which goes from Rm to Rn. This is an Euclidean space with m dimension and n dimension. And also we are given with the condition that the range of Q is equal to the range of P, and this is crucial here. Now one might wonder what happens if we transform P over Q, that is, take any vector x and first transform this with the transformation Qx. Now if you apply projection over this, will it be any different? Okay, now we have Q of x is equal to y, which belongs to Rn. Now if you just consider P of y, which is nothing but P of Q of x, we get P of y is nothing but y, because y belongs to the range of P, and we can represent y as y plus 0 here, and 0 being a vector in the null space. So P of y is nothing but y, which is again nothing but Q of x. So what we have here is PQ is equal to Q, which is the second option.